Hello everyone, we're going to talk about the PVD deposition process basic knowledge. PVD as we talked about before. For example, the deposition TI material can use the DC advanced power. The deposition NIV material we use the dB pulse power. We can use the DC power in different wave to do the process of the deposition. And why we use the DC power, not RF power, just we talked about before. This is the PVD character. The basic device up the chamber is like this figure. This is a drive motor and it's the plate to connect to the DC power, and above the chamber there is a magnet assembly. The magnet affect the uniformity very huge. The uniformity, good or bad, depending on the gas steady condition and the power and the target condition, and also the magnet. The magnet is a active uniformity maker device. PVD use the chamber braking system like others. The process braking level until 2, approach 2, this level very low. So the process chamber connect the pressure transducer with the 100 torque to active the one stage pump, 10 torque and 50 millitorque to control the two stage pump, you mean the turbo pump, and the star to ready for the process, and to use the process pressure transducer to measure below 0.1 millitorque. And then this PT has the issue. The process will have the issue. So this is more important. Equipment facility piping also has its spec. The particle, for example, the particle below this size at most just one. And the extreme elementary below 10 ppb, and the moisture below 2 ppm. This is just for example for inferior equipment. The superior equipment is higher spec than this to execute more superior process. And this is the top of the chamber, and this is the magnet device. There are marks here and here. This mark just after adjustment the magnet position, we keep the mark because the magnet can move this way and move this way, move this way and move this way to adjust just for the uniformity. If you have a uniformity issue, you can adjust the magnet to the uniformity bad places. Then process deposition the metal again to see trial and error. Final position is the best condition, and we mark it. Process engineer parameters of control. The basic PVD control parameter, that's just like after deposition, the stress condition. We call it wafer workage level. Anyway, we don't like to see the wafer workage too seriously. And the thickness per time, deposition speed. The unit most likely is how many electrons per minute. It's the deposition speed. And we control the ice value and its uniformity. The surface resist value and its uniformity spec. For example, the TI material. The ice value want to measure to be 6.5 to the 8.5 is a range. Inferior equipment has the basic range, for example, just like this. And for example, the uniformity below 3% is a basic inferior equipment performance. And reflectivity also need to be a parameter to control. The reflectivity above 100 value. This is for TI material to do the spec. Okay, it's the basic PVD deposition process basic knowledge for it. And the more detail I'll show you later in another chapter. I shall see you next time.